Okay, here we have a percent composition example. The problem says calculate the percent composition of iron in Fe3O4. So we're given this formula, there are no numbers here, and we're just asked to calculate a percent composition of iron. First thing you need to do is grab your periodic table and locate the elements in that formula. We've got iron, which is Fe, and oxygen, which is O. And what you need to realize is that these numbers on the periodic table represent the molar mass, or the average atomic mass, of the element of interest. So 1 mole of iron weighs 55.845 grams. That's a conversion factor. And 1 mole of oxygen weighs 15.999 grams. The second step in this process is to calculate the mass of iron in 1 mole of Fe3O4. Now, a lot of students do this on their calculator or just in their minds, and that's fine. They know that this is the weight of 1 iron. There's a 3 in the formula, so we need to multiply this number of iron in the periodic table by 3. Let me show you exactly what's happening here with the units. We have 1 mole of Fe3O4, and we know we're multiplying by 3 because there are 3 moles of iron per 1 mole of our formula. And then from the periodic table, we know that 55.845 grams of iron is equivalent to 1 mole. And like I said, a lot of students just do the 3 times 55.845 and get the answer, and that's fine. But if you use units, it'll further reinforce unit cancellations that we've seen before in the class. Do the same thing for oxygen. Oxygen, we have a slightly different mass, 15.999, and we have a 4 in the formula for the subscript indicating the number of moles of oxygen per 1 mole of the formula. So here we do 4 times 15.999 on your calculator, and that gives us 63.996 grams. Okay? So again, we have all of these conversion factors that probably you're not even using or aware of, or skipping that step. But that's fine, as long as you're doing 4 times the number on the periodic table. Now we've got the mass of iron, we've got the mass of oxygen. What we want to do is calculate the molar mass of Fe3O4, and we get that number just by adding these two values together, and that gives us the molar mass of Fe3O4. In other words, 1 mole of Fe3O4 weighs 231.531 grams. Our last step is to simply calculate the percentage of iron in Fe3O4, and we do that by taking the ratio. So in the numerator we have the mass of iron, 167.535 grams of iron, and in the denominator we have the molar mass of Fe3O4. Don't forget to multiply by 100 and express the number as a percent, 72.36% iron, and that's the final answer. You can do that with any formula, just use the periodic table and the appropriate atomic masses, and that's it.